very much. I appreciate being asked to come and speak in this workshop. I think some of the work that I've done looking at mechanical methods for restoration and specifically pine flatwoods is kind of a nice fit for looking at different tools and technologies for restoration efforts, particularly in longleaf pine. So this is my first range meeting, and I was a little unfamiliar with what the audience was going to be, so I didn't know exactly how technical or how much to talk about longleaf pine or not. So I thought kind of what I would do is just kind of give a general discussion of these mechanical treatments, and then show you a little bit of what it looks like in longleaf pine flatwoods here in North Florida, where I did the majority of my work for my dissertation at the University of Florida. And so we've seen Janet had brought up some mowing techniques that were being used on the Kalamazoo forest. And mechanical mastication, I didn't pick this term specifically because I was coming to a range meeting, because this looks like they're kind of diesel-powered cows out there masticating the world. This is actually a term that, kind of an umbrella term that we've been using essentially for mowing or chipping or mulching of understory fuels in the literature, and more often the term mastication is used out west, at least. I don't hear it that much in the field or with managers in the southeast, where mowing is a more common term. But what I'm particularly focused on when I talk about mastication is primarily the front end type of equipment. A masticator head is on the front of a ground-based equipment. It's either horizontal spinning blades, kind of like a mowing deck, or a drum with fixed or flailing teeth on it. And the advantage of having it front end, and I'm certainly not a mechanical person. Most of my work in this arena has been looking at the effects that these treatments have on fuels dynamics from a fire perspective, their effects on actual fire behavior and fire effects, and some of the ecological implications. But the advantages is the operator has hydrological control of that masticating head, so they can control what they're mulching, and they can control the intensity they're mulching, and probably most important is they can keep that masticating head off of the soil and try to minimize soil disturbance compared to equipment that might be pulled behind, some equipment like roller chopping or something like that. The masticating heads can also be boom mounted. I see this more often out west. It's quite impressive to actually see a masticating head just chew a small tree from the top all the way down to the stump. So they can be used in that fashion. And so kind of the objectives of these treatments, the topic here is talking about restoration, but also this tool is used as a fuels treatment specifically to try and mitigate fire hazard, to try and lessen fire hazard even in wildland urban interfaces, or even on larger landscapes. So if we think about some of the changes that occur from these treatments, from a fuels perspective, the primary objective is to essentially reduce shrubs or small trees and convert those vertically oriented fuels, as we call them, or ladder fuels, that might allow fire to run up into the canopy of trees and mulch that down into essentially a highly compact surface fuel. One thing important to know with these treatments is these stand alone, these aren't a fuels reduction treatment. We hear that term a lot, fuels reduction. But the fuels aren't actually reduced here as far as loading. They're just redistributed, okay? They're reallocated to densely compact surface fuels. And so some of the effects you might see if we think about it in a restoration context, if we want to open up canopy in areas that have gone long unburned, or there's been maybe hardwood encroachment, in longleaf pine sandhills here in Florida, or white fir encroachment in ponderosa pine out west, is it opens up that understory and that forest floor to more sunlight, which might promote, the other herbaceous grasses or forbs that might be a target restoration groundcover species to establish because of that increased exposure to the sun. But one thing to note is unless these fuels are taken off-site somehow or followed up by prescribed burning, is this is creating a mulch layer. And some of the things that I've looked at out west is there's a really heavy mulch layer, just like when you're walking around outside and looking at some of the landscaping here and thinking about getting some of these herbaceous species to maybe come into these systems. If there's lots of heavy surface debris, that may be an issue for restoration efforts. In the southeast, a lot of mastication treatments, especially in the flatwoods that I'll talk about, they're primarily being used as a pre-treatment prior to trying to get frequent fire back into these systems. We're not as often using these as a standalone treatment. So one of the targets is to essentially consume those fuels with fire. Thinking about it from a fire behavior perspective, and this is kind of more of the priority of the kind of work that I do, is essentially by converting these vertical ladder fuels into a dense, compact surface fuel, you're kind of limiting or trying to reduce the chances for a canopy or crown ignition, and reducing fire intensity or fire hazard in that sense. But there is a trade-off if you think about these dense fuels, a mulch layer on the surface, is you're trading the potential for heating of the canopy for potential long-duration heating at the forest floor. And some work out west has looked at some long-duration soil heating, which might be problematic in some of these systems. Long-duration smoldering that may occur for a long time after ignition or after a wildfire may burn through, or even under prescribed fire conditions. So there's challenges to some of these things when looking at it from a fire behavior perspective. And if you think about what you might be doing by creating these dense, compacted fuels, is you're essentially creating a mulch layer. One of the reasons for mulching and landscaping is to retain moisture. Okay, so by adding these and compacting the fuels, you may be enhancing moisture retention. Some of the work that I did out west was looking at some of the moisture dynamics in these densely compacted, masticated sites and like manzanita shrubs, and we've shown that they really can retain moisture. But if you think about the structural changes in forests, you're essentially opening to more solar exposure, which might increase heating of those fuels, which may exacerbate drying, and you're also opening up those surface fuels to more windy conditions too. So there's some trade-offs. And so thinking about the effects of these treatments, it's really going to depend on where you are. Okay, there's really no, the bullet answer. People will often ask me, is mastication good or mowing good? Can you use it? Well, it really depends. Depends on the system we're using it in, depends on what your specific objectives are. And you can see from these photos here, there's quite a bit of variation in what the surface fuels look like following these different treatments. In the upper left, that's a masticated site out west where it was a very old shrub component, so lots of dense woody material on the forest floor. Other areas where there's not as much canopy cover, when the trees are treated, there's not as much fuels on the ground. Then that lower section was lowered to as a masticated site on the left in a pine flatwood, and on the right is actually the vegetation response following those treatments. And that's something that I wanted to point out by actually taking a look at what do these treatments look like in pine flatwoods in the southeast. The southern part of the coastal plain, flatwoods are typically dominated by longleaf pine or slash pine or a mixture of the two. But it's been alluded a little bit in a couple of other talks about flatwoods that they're quite different from the sandhills that have been talked about, where the target for restoration is to have this nice golden sea of wiregrass and lots of herbaceous species. These systems are very flat. They're often inundated with water, mesic or even hydric, and even though they're coarse sandy soils, but the understory component largely composed of shrubs, and most of that is often gulberry and saw palmetto. Palmetto being a very unique shrub compared to lots of other systems where these types of treatments are being used. And so the Osceola National Forest had started to do a lot of mowing treatments in these flatwoods areas that had gone quite a while, quite a few years before they had burned, with the intent to try and just knock these shrub heights down and then try and get these compartments back into a more frequently burned regime. And so at this time, about 4 years ago, I think they were treating about, it was 8,000 acres or 10,000 acres, basically along the I-10 corridor, several compartments that had gone long unburned. So there's maybe some restoration issues here, but there's also an issue of fire hazard along the interstate. And so we actually looked at several different things by using the sites that they had treated. So we looked at the fuels dynamics, essentially looking at the components from a fuels and fire perspective prior to treatment, following them for about 2 years to track what were fuels doing. We looked at vegetation response. We actually set up experiments, both small-scale laboratory experiments where we burn fuel beds and also larger stand-scale experiments where we looked at the actual effects that mowing had on fire intensity, flame lengths, and rate of spread, and looked at the effects on fire effects to see how much these treatments were actually influencing fire when we put fire into the system, and also looking at several different ecological effects of these treatments. And I won't go into a lot of detail of what we did because we looked at quite a different variety of things from several different perspectives. I just want to kind of show you what it looks like. And part of this, for the audiences that are not familiar with the Southeast, is kind of what came to me. I've been in Florida almost 6 years now, and I came from the western U.S. where I was working in quite different systems. And when I seen mowing in these flatwoods, there was some obvious major differences of what it looked like, what the fuels looked like, and then we'll get to what the vegetation response was. But essentially, the mowing did a pretty good job at altering that understory component. So this is about an 80-year-old stand. The understory was mostly gallberry and palmetto, about 1.5 meters in height. There was a few smaller hardwoods that would come into these areas, but I think they're a little more resilient to encroachment by hardwoods than some of the other sites because of how much the shrub component is. But you can see here what was a sea of palmetto and gallberry has now been knocked down. This is immediately following mowing. And so a couple things to look at from a fuels perspective. On the top here, if you look at surface fuels, the stuff in the yellow where I have this 1 hour, 10 hour, and 100 hour, those are basically just woody fuels, and that's how we categorize woody fuels by different diameters. And then the green is a litter, okay? And this was what was very striking to me compared to the stuff we looked at out west. We really didn't have a lot of compositional changes from the fuels perspective. Essentially, they're dominated by foliar litter, whereas a lot of the masticated sites out west are heavily dominated by basically small diameter shredded wooden material. So this looked quite a bit different to me. And thinking about that from a fire behavior perspective, that's quite a bit different. Thinking about how long that stuff might decompose if it's not burned afterwards was striking to me. Ground cover, I thought, from a restoration standpoint, even in some of these systems, some people argue about how much palmetto should be there, and of course it depends on the site that you're at, how wet those sites are. Some restoration efforts would like to see cover of palmetto reduced and some more wiregrass come into these systems. We'd like to have more herbs in these systems as well. We had some evidence, just looking at the treatments themselves, that a year out we had some more grasses coming in. These are wiregrass, and a little bit of herbs, but not much of a change. So we had a bit of evidence of wiregrass coming into the systems. This is very different for those of you that were looking at these sandhill shots earlier, where essentially cut down a bunch of sand pine, and then what you're trying to get is a whole sea of very nice golden wiregrass. So this is quite a different system. But also, this is a system I like to point out that is a frequently burned system. Every maybe 3 to 5 years, these systems do burn. But the shrubs respond to fire very well, okay, which is why you need to burn every 3 to 5 years. And that shrub component is what's driving fire behavior when these systems do burn. And I think this is kind of a striking photo from the perspective of post-treatment vegetation changes. I kind of have from the low, moderate, and high, we have kind of different levels of how much palmetto is a part of these components. We're really interested in looking at flatwood systems of how much palmetto is in there. We use it for lots of different things, even for our food models. But on the left column, across even those different palmetto densities, that's 3 months following mowing. That was very striking to me that most of these shrubs in here were sprouters, and they were sprouting back very rigorously, okay? And so they were coming back very quickly. At 9 and 18 months post-mow, I mean, things didn't look like a whole lot different than they had prior to the actual treatments, other than there was definitely a height difference. We did have some evidence that in some areas we were showing less cover of palmetto than in other areas. And I think some of that may have had to do with how wet these particular areas are. We haven't really teased that out. But another thing we want to look at is how does mowing look in conjunction with burning? So a lot of the objectives here is to get in here and mow these sites and then follow up with prescribed burning. And so we set up some experiments where we had sites that were not mowed and we burned them, sites that were mowed and we burned them. We had sites that were mowed that we didn't burn and control, so we can look at these over time. We want to continue to retreat these with either burning by itself or mowing by itself or some kind of combination to kind of look at the effects. So, one thing of interest was I wanted to actually try and quantify the effects on fire hazard. And there certainly was a quantifiable effect in the mowed sites where the flame lengths were quite a bit less, averaging about 1 meter compared to about 3 meters in untreated sites. Rate of spread wasn't really altered, but of course this was during prescribed burning days where they weren't that windy. You can notice consumption in both areas were pretty high, and pretty much as far as the area burned, that's pretty much what everything looked like. Since palmetto is such a shrub of interest, I'll show a little bit of data here. You can see the 4 different treatments that we have: burn only, control, mow plus burn. And we definitely have, starting out I have immediately following the mowing, and then following burning, and then a year post-burning. There was significantly less palmetto in the areas that had been mowed. After we followed up by burning, there was no difference between those sites that had been burned and those sites that hadn't been burned. Essentially, it was no double whammy effect. If we went in there and mowed it and then burned it, we didn't see an increase of loss in palmetto. But of course, this was only following 1 mowing treatment and 1 burn. We don't know what it would look like if we continued to maybe mow this every 3 or 5 years, or we continue to lose palmetto, or if we continue to burn, what might happen. We did have some evidence in the mowed-only areas that we had increases in grasses. We did a workshop about 7 months following the burn, which was about a year following the mowing treatments. And at that time, we did show some increases in wiregrass in the areas that had been mown, but not in the areas that were mowed plus burn. Of course, there was some seasonality here too, since sites were mowed in August and we burned them in February. But like I said, we have some different results about how much grass we found following mowing, but it seems like increases have only been slight. And I do want to point out that for those that may be interested, we did put out a photo series, a Fields photo series for these treatments. And I don't think we've had them printed yet. I'm not sure if it's available online. Hopefully we'll have that online soon through the Joint Fire Science Program on the Southern Fire Exchange. But essentially, those of you who may or may not be familiar with photo series, it's a manager can take a look at these photos and it'll tell them kind of a breakdown of what fuel components they have that they can plug into fire behavior models. And we have it set up based on the time since treatment because of the response. So just to kind of look at some of the key questions and issues that we still have. What are the efficacy of these treatments? If we used it as a standalone in the wildland-urban interface, what's the longevity of that treatment? Because in this system, the shrubs seem to respond fairly quickly. From a restoration standpoint, obviously we can use it to remove hardwoods, potentially reduce palmetto and increase grasses, but again, if we used it more often, what would that look like? and essentially, can we restore frequent fire to the system? And that's mostly what these treatments are being used. But some issues with prescribed burning is, can we consume the masticated debris, and what conditions can we burn to consume that masticated debris? Is it dry enough without trying to limit any overspring damages? It's kind of a whole other talk. But with that, I will leave you with about a year's regrowth following treatment.
We've got time for one question.